that's how we'll start then. Cool. So yeah, thank you guys for letting me come and talk again at another Elastic event. I gave this presentation, I think, a few months ago, back before Corona hit, at Danske Bank in Aarhus. We have a small Elastic community that we're trying to build up in Aarhus in part of Denmark. That last presentation took around an hour. This isn't going to take an hour. This should hopefully take half an hour. I've tried to cut out some of the stuff that was in the previous presentation to make it go a bit faster. So I need to keep an eye on the time. So let's see how we get on. So one of the things you will notice at the start is that I'm not actually presenting as JN data. I'm doing that on purpose, and that's because if I present underneath my my open source blogging part, then I can give out the slides afterwards. The tool that we actually built that started in JN data and then kind of spread out further out is open sourced, and it's open sourced under my my part because we took it on afterwards. So it's easier to talk about it underneath this banner rather than have to worry about going through any data classification or anything else like that. So that's why you see the security distractions logo on the screen instead of JN data, just to give you the background there. So I will jump through a tiny bit about me. This is me when I was much younger than I am today. This was around 5 years ago. This picture was taken when I first moved to Denmark and I was fresh, before I had 2 kids, and now I have 2 kids, and I also have a wife. That's me. I am the current Cyber Defense Center Department Manager working at JN Data. I still love to get involved in quite a lot of the technical stuff. My role is determining that I'm not doing that as much anymore, but I still do some stuff outside of the office when I have time for it, and that is again focusing on my open source side of things, and that's where I tend to stick to my security distractions blog, which I run with a friend / colleague at JN Data. So go check it out. There's quite a lot of stuff on there about Elastic. I'm tending to move towards more incident response writing at the moment, but there's still some really exciting stuff on that blog, I think, in terms of the work that I've done with the Elastic SIEM, and also some information about the tool that I built, which we'll cover later in the talk. So go check it out. Again, the slides will also be up on the GitHub, which is part of this securitydistractions.com as well. So hoping that that you guys can find it if you go to the site, if you would like to have the slides afterwards. So cool. So let's do this. So a slight introduction to this story is about how I built the open source detection lab that we needed at JN Data, but then that I then moved out even further out so I could start playing around and learning and also teaching other people about Elastic and also about doing, I want to say malware analysis, but you know, looking into malware and seeing what's it calling out to, and also building a kind of a lab that we could come into and run different tests against domain controllers and things like that and actually get all the logs out. So this is a story about how I built that lab and how really distracted I got in the process. So we'll look at the why did I need to do that, the how I did it, and then the actual distraction. So the why. Why did I build this open source? I did it because what you tend to hear in the field or in the security business is that detecting threats is expensive, and it doesn't have to be expensive at all. It's not expensive if you don't have to pay for anything, and that's the cool thing about Elastic, and that is that it's open source, so you just put it down and you can piece it together. Of course, if you would like some sort of enterprise solution, then yeah, you might want to pay for support or something else. But for the purposes that I wanted, for my own lab and for my own further learning, you don't actually have to pay for anything. So that was the really cool thing, especially now Elastic have added the SIEM functionality, because that is, yeah, that's some cool stuff, and to not have to pay for it is even better. So So then the question came, can I actually do this? Can I build some detection capabilities where I'm only using open source tools to do this? And let's have a look. Then I go back into, okay, well, how can we do this? So what I really wanted in my lab was a Windows 10 workstation. This was just so I could start playing around with, the latest operating system at least. I also knew that I wanted it to access the internet. And so since I love open source stuff, and again, I know I've already gone a bit wrong by saying I'm doing open source and I start with a Windows 10 machine. But that was, again, because I still wanted to have an environment that was similar to what I worked with in my day job. So I also put a pfSense firewall in. I knew that I wanted to connect it to the internet, so I knew I needed to build some sort of LAN. I also, again, open source, but again, I wanted to have a domain controller in here so that I could actually get logs out of there, and so that I can actually see what happens when I maybe execute malware that's going to target a domain controller, or where I target the domain controller myself from a workstation using Empire or something else like that might generate some detections. I then called it my crown jewels because that's where I have all my special stuff. I built a domain between the two, which I called secdis just because of the shortening of the name. I also knew that I wanted a proxy server, so I could start intercepting traffic between the Windows 10 machine or the domain controller and the internet, so I could look inside maybe command and control traffic. I also decided that I would like some sort of IDS. And the cool thing about this is that Suricata comes part of pfSense, so it was quite straightforward to do this. The same with the Squid proxy server. Squid comes built into pfSense. Originally, I used Squid on its own, but then I don't know how many people have used Squid before, but the nice part of using Squid on pfSense is that the pfSense also has certificate management as well, so it becomes much easier to handle doing interception when you use Squid as part of pfSense. I also wanted some sort of DNS setup. Of course, I could use the domain controller for that, but I also wanted some sort of external DNS setup, so I used a Pi-hole as well. I also had Elasticsearch in here. And then again, this is a legacy drawing, but this drawing was made before the seam tool was released, so I was using ElastiAlert back then. But in terms of looking at this, you can just look at this as actually ElastiAlert's not necessary anymore. I also had a tool called the Hive, but we won't focus on that right now. That's just a tool for where the alerts would go to if I wanted to send alerts to something. And then last but not least, a tool called MISP, which we'll talk about a tiny bit more throughout the presentation. I called this my utility LAN, and that's it. That's the drawing of the lab. So does it make sense? In terms of actually understanding how the lab is actually put together and the actual the process that you need to go through, let's look at a more simple drawing of. So we have our workstation. We need to go to the internet. So let's say that we want to go to www.totallylegit.dk, and here's the IP address. What the Windows 10 machine is going to do is it's going to go down, it's going to ask the domain controller which I set up as a DNS server, hey, can I go and get this DNS address? And I'm not going to talk about exactly how a network is put together. You guys should hopefully know that. But essentially, it makes a DNS call. This is just to show where there's potential for logging in each section. It sends it to the proxy server, where you can see that it's logged the domain name and the IP address, Suricata, the domain name and the IP address, and the pfSense firewall, where it's just logging the IP address. And it goes out onto the internet. And I call it host-centric, and you'll see why it becomes host-centric in a bit when we actually start looking at how the logging inside the lab is put together. I want everything to be centered around the host. So even though each security tool, or if you call it security tool, even though each tool is logging its own individual set of logs, it's still in relation to the original request that was made from the original host, which is why I call it host-centric. And that's one thing that some people tend to forget about when they actually look at using Elasticsearch and these tools, and that is that instead of looking at them as all individual logs, you should look at them as basically in relation to the original thing that started this process. And that's why I call it host-centric. And hopefully it gets a bit clearer as I talk through the next parts. So how am I doing on time? Good, I've got time. Yeah, so this is a logging talk. So where the hell is the logging? It's coming and it's here. So I'm going to burn through this very quickly. Here are my logging sources. These are the sources that I just talked about and said the different parts that they play inside the lab. So these are bumped down inside this little section here. They go inside log sources. From log sources, we obviously need to ship those logs somehow. So the logs that need to come off of the log sources, there are different ways that they can come off, but we'll look at that in a second. They then need to be normalized. Now, this is potentially one of the most important steps in this entire host-centric logging vibe that I'm trying to build up, and that is this normalization step. And when it comes to normalizing, we're going to need to find a schema that we can use to do that. And it's well worth remembering that this doesn't just have relevancy in my lab, this has relevancy in an enterprise logging environment as well. One of the most important things that you can do is normalize your logs against the schema. After it's been normalized and set up, you can enrich. And there's a reason why it's done and normalize first and then enrich afterwards, and that's because if you can do the normalization first, it's much tighter. You can do enrichment only once after that, and you'll see that in the next couple of slides as well, how that's done. After enrichment, we're going to want to transport the logs, so we're going to want to send them somewhere. So in this example, we're going to send them to some storage where it's going to be indexed, so we can do some searching. We can do queries, we can do visualizations on the logs once they're actually stored and they've been enriched. And then afterwards, we can do some sort of detection based on those queries. So it's a really important thing to remember that a detection is basically just a query that's returned true. That's the most important thing to remember when I draw this line from detection over to query, because a detection is just a query that's basically gone off and true. When I look at actually, and this is a short step, you can see I've cut something out here, and that's because I'm just going to overlay where the different tools in the Elastic stack actually fit over the top. And when we talk about shipping, that's beats. That could be file B, that could be metric B, that could be packet B. All the beats family are shippers, and they are what you would use to extract the log files and then move them through the system. Now, I still use Logstash. Other people are starting to switch over to different stuff, but I think Logstash is incredibly important, especially when I do some of the enrichment that I do that we'll come into in a few minutes' time. These steps are all done within Logstash. I also use Elasticsearch Common Schema, and this was really a game changer. Originally, the normalization that I chose was based on my own model, but since Elastic have released Elastic Common Schema, it's been a bit of a game changer. It was a long time overdue, and now it's here. It's a really, really awesome schema to look at. So if anyone's coming into this question or coming into this thing and needs some help figuring it out, I highly recommend looking at ECS. It's really awesome. Some of the beats are starting to conform to it. When log beat is conforming to it, everything is centering around this, and it's a very, very powerful thing when you can actually start using it. And again, we'll look at this as we go through. For storage, of course, we have the daddy of all of it, Elasticsearch. After that, we've got Kibana, where we can do our queries and our visualizations. And here it says question mark, question mark, question mark, and that's because at this point, when I made this original presentation, we didn't have the glorious seam engine that we now have as part of Kibana. So I know Morten Feinu would like me not to talk about what was there before, which was ElastiAlert, but this is just a sign of the times. And now Kibana has come so far that we have detection inside Kibana, which is really, really cool. So I didn't mention any correlation. And the usual point is, you need a seam tool if you're going to do correlation. And actually, you don't at all. You can actually do correlation by just using a schema. And that's why I say that if you use a schema, you can correlate at ingestion. And that basically means that providing that you organize your logs as they're actually being ingested, there's no need to have a special tool that stitches it all back together after it comes in. You can actually just, if you choose the right schema, they all align themselves together as they're coming in. And this is, again, about having control of your logs. This is not just about just spamming logs into an agent somewhere and hoping that the tool then afterwards will come and basically be like, oh, that's an IP address, that's an IP address. This is the same thing. This is about taking control of your logs and getting in front of them and getting them under control. And that's what I'm going to talk a little bit more about as we go through. So what does it mean when we talk about this schema and how does it work? So if we have if we go back to my lab where we had the Squid proxy server from before, and we have Suricata, and we have the Pi-hole. So as you can see, they're all basically showing a domain name, but they're all got different field names for that domain name. Now, if we wanted to write some sort of alert that said, I want to know when someone accesses www.totallegit.dk. Well, in this scenario, there's 1 pattern, 2 patterns, and 3 patterns. So that basically means that we would need to make 3 rules to alert on this domain. And that's not the best, both for performance, but also for the number of rules that you might end up having to create. And so this is also not correlating at all because you've got 3 different patterns here. So what can we do? Well, we can look at them and say, okay, what does ECS give us? What does Elastic Common Schema give us? So if we look at these and say, okay, well, these are essentially a destination domain name. Okay, what do we have in ECS that will support that? Well, we actually have destination.domain. Great, done. So if we map our log sources up against the schema, we can actually put all 3 of them through logstash and align their fields with destination.domain, and then we end up with 1. So when we actually go into each of the log sources or to the indexes, we can actually see that, okay, the Squid one says destination.domain, the Suricata one says destination.domain, and the Pi-hole says destination.domain. That means that if I want to write an alert whenever we see this, I only have to write it against 1 pattern, and that is against the destination.domain. That means that I can span across multiple indexes and look for just 1 pattern. And that's awesome. That's, again, correlation, and that's correlation without having to spend a massive amount of money on full-blown seam tool. You can just do this by just taking a small bit of control over your logs. And you don't have to do this for every single field. You can choose a handful of fields if you really want to just get going with. That's really the power of ECS. There's also other parts that come in where I talked about host-centric correlation. How does that work? Well, let's go back to the host name this time. So let's say that the Squid proxy server, that logged the host name of the Windows 10 machine, and the field name was host name. With Suricata, we had a source IP. Maybe we don't have the host name being logged. Okay, what can we do about that? In Pi-hole, maybe it logged a source host. Okay, cool. So the first thing I can do is I can look at these 2 and I can say, great, well, what does ECS, again, what does Elastic Common Schema give me to solve this problem? Well, I have host.name. Okay, let's settle for that right now. Let's look at that. That's great for those 2. Those 2 now I can map them up against the common schema, and now I can correlate. So again, across both those indexes, the host name has been correlated, and now it can become host.name. That's great. Now we have the problem of the Suricata logs. What are we going to do to be able to fix that? This is when the enrichment step comes in. Now, this can be something as simple as doing a quick and dirty reverse lookup for this IP address against the domain controller, because we know that this is part of the domain, so potentially there's already a domain name in there. And that can allow us to then enrich the source IP to the host name. Ding, we have hostname enrichment. So wherever we would have hostname or wherever we would have a source IP, we could also then get the hostname out of it by doing some simple stuff with Logstash. Now, this is free. Everything I'm talking about here is totally free, apart from the infrastructure you do it on, of course. But some of this stuff is quite quick wins. Now, there can be some interesting stuff when you start doing reverse DNS lookups and things like that. So I would highly recommend that you are careful before you start doing that. But it's one useful way of doing enrichment that can enable you to get into ECS and then map things up against host.name. this is where and then I say host-centric correlation, because now all of the log sources are correlating, and they're correlating around the host name. Now I've still got, what, 12 minutes, that's perfect. Now 11, damn. So that only covered one domain, right? So that covered when I said I want to do an alert on www.totallylegit.dk. Now, what if I want to do it on on a dynamic field instead? So instead of talking about a static, okay, I want to alert on this exact domain. No, I want to alert on a list of domains, as an example, or on an ever-changing list of domains. Cool. So how can I also look at other domains that could be threats? And then can I get some threat data into Elastic? And as of speaking, I'm not sure that Elastic has this out of the box yet. I haven't heard anything about the new versions of the SIEM platform. Maybe there is something hiding away coming, I don't know. But at the time of doing this and for the last period, there hasn't been an out of the box solution that can solve this. There's been some blog posts into how to do this, but we had a need to design something and to implement something that could do this. So here's where the massive distraction comes in. A security distraction, see? Sorry. Yeah, you see what I did there. The plan. So what was the plan originally in terms of actually being able to put this together? Well, the first thing we had to do was we needed to get some threat data. So we would like to get some domains that we want to alert on. Cool. We would then like to combine it with something, and then that would give us some profit, which would be the enriched logs. Now, we also had some requirements to it. Now, this is remembering that this was built inside an enterprise environment originally, and in this scenario, back then we had around 100,000 events per second. I think we're pushing way more than that now. But this was just to say that we wanted the solution to be scalable. So we wanted it to be able to enrich over 100,000 events per second. And we wanted it to be real-time enrichment, so speedy detection. So as the logs are actually coming through, we wanted them to be enriched so that we could then detect straight away afterwards. And that proved to be a very entertaining thing to try to figure out how to do. Now, when we talk about getting the threat data, there are a number of ways of doing it. There are a number of lists out there you can consume, but we wanted to use a tool that we were already using in-house, and a tool that is actually built for supporting dynamic threat data, not just threat data, but also used for threat intelligence. And that is a tool called MISP. There is a lot of people using it around the finance industry, at least. And so some people should hopefully know about it. If not, this is a quick, not deep dive at all, but a quick mention about it. MISP stands for Malware Information Sharing Platform. It's a threat intelligence sharing platform. It's not just for threat data. In this scenario, we're using it just to do threat data, just to show it, but it's used for a lot more than that. It's developed by Circle down in Luxembourg. There's some really, really cool guys down there. It was originally a NATO project. And they have a really great API that you can use for automating loads of some really cool stuff. And this is just an example just to show part of what can come out of MISP and to actually show that, okay, in this scenario, you can see that there's down a category network activity type domain, domain1.com. We can assign some tags to it, like here you see feed alert. And this is where I really wished I had my laser stick or something so I could point to you to show you how different bits to come together, but I can't. But essentially, you can add tags to specific domains and you can have those put into a specific list. And then from that list, you can pull that list and you can do something with it. And that was basically the part of why we wanted to use MISP. So now we have MISP as our threat data platform. What about the question mark? How are we going to solve the question mark? Well, we did some whiteboarding, me and my friend, colleague at work, and a lot of discussions later. And we came up with a tool that we call, well, back then we didn't call it this, but this was my idea to call it this, so I'm stealing the name. And it is, some great security guys have written an integration between Elastic and MISP. It does ingestion, it does enrichment on ingestion in real time, scalable. It has support for ECS field types. At the moment, domain IPN SHA-256, and this was a while ago. I haven't actually been maintaining it recently because life has got in the way, but it has support for these types. And this is what it looks like. Now, again, I wish I had my pointer. Maybe you can see my mouse. I hope you can. We start with MISP here. I put a tiny bit of a Python script together. I'm not a developer, so excuse the Python script. You'll see it if you look on the GitHub. But the Python script basically goes and pulls the list of domains from MISP that have got a specific tag assigned, maybe alert, domain list, or something like that. You can use ransomware tracker. There's all sorts of stuff that MISP actually provides out of the box that you can actually start just enriching and playing around with. I use MISP again because it allows you to basically pull in loads and loads and loads of lists and correlate them through MISP first, and then I use this Python script to come and pull it, and then I use the Python script also to push the data into Memcache. Now, I use Memcache because when we realized that we wanted it to be scalable and we wanted it to handle over 100,000 events per second, we realized that this was not going to be something we were going to handle with HTTP requests or anything else like that. We wanted it to be stored in memory. We wanted it to be done fast. So application running on Logstash or on our Logstash servers. And then Logstash has a plugin that I think is now fully supported. I can't remember if it's fully supported now, but I think it was on the way to being fully supported. But it has a Memcache plugin. So Logstash will actually essentially go and query its memory and say, hey, do I know about this domain, as it's then writing it back to and then sending it off to Elastic. So what you see in this picture is you've got your logging sources on the left-hand side. They're sending logs into Logstash. As the logs land in Logstash, Logstash is basically saying, cool, I've got a destination.domain there. I'm going to go and look it up against Memcache. And then if I get a result, I'm going to send it onwards to Elastic. And so here's actually how it is functioning. I've got 5 minutes, so this is perfect. Again, this is after we've done our normalization. Now, this is what I said I'd come back to. The perfect part about having enrichment after normalization is that I've got 3 fields here that I don't have to change the pattern for. I can basically send in these 3 indexes with the same destination.domain pattern, and I don't have to write anything special to handle the difference in the Suricata log to a squid log. They all use the same schema, and that means that they are, they're ready for enrichment. When I take these, all of these go into my little enrichment bubble here. This enrichment bubble is based on going and querying and working with ElastiMISPStash. What that does is go and look up this list of domains here. Now let's look and say here, okay, cool. So in this list of domains, you can see that the totally legit.dk is actually in there. It gets a hit. It writes back a new field called misp.hit. As an example, you can change this field yourself if you start playing around with it. It sets it to true or sets it to yes. And then I can build a very quick detection, a very quick and dirty detection as well against that field there. And if that field is ever set to true, I can then say, great, I would like to detect that. And this tool is there on GitHub. It's available for people just to use. It's been open source quite a long time ago, and it works. I know people have actually downloaded it and used it. And if you actually go to the securitydistractions.com blog as well, you'll find that I've made a 3-step, 3-page blog or 3-post blog entry, exactly how to switch it on and exactly how to use MISP as well in terms of actually getting this up and running. So if you want to play around or if you want to implement something like this, it's really, really not massively difficult to start playing around with. So once you go to set misp.hit to true, you can build your detection against it. So what did we learn? And this is the last slide, so this is almost perfect timing. I can't believe I did it in under half an hour. That's awesome. Detecting threats is expensive. No, it's not, because again, it's not expensive if you don't have to pay for anything. Some of the take-homes, detection and logging doesn't have to be expensive because this was all done with open source tools. All of the stuff that I talked about, even doing correlation and alerting now, is all handled within one open source platform, which is Elastic. Correlation can be done for free by using a strict logging schema. So if you just settle on something like ECS, as I said earlier, that's it. You don't need to do anything else. And it also means that you get more control over your logs. You know what's supposed to be coming in. You know what they're supposed to be looking like. and you get them earlier in the engine, and you can have way more control over what's supposed to be flowing through. And that means when you're writing alerts, you know exactly what's supposed to come out the other end as well. If you control what's coming in at one end, you know what's coming out at the other end, which is perfect. ECS is really, really awesome for that. Host-centric logging craves enrichment of the host field. Well, yeah, it does, because otherwise how do you do host-centric logging if you don't have the host field enriched? But this is the one thing I will stress. I know I've made it sound easy until now. It does take time and commitment to get there. You really do need to understand your logs, and some organizations, they just want to throw something in, they want to pay money, they want to just say, yeah, we bought this big SIEM engine, it does everything for us. It doesn't. No matter what tool you buy, you still need to do some of this stuff yourself. It's not, it shouldn't be an excuse to avoid having an understanding of how your logs are put together. So inside this scenario, you do need to learn your logs. You do need to know them inside out, but that should be something that you should do if this is something you're willing to dive deeper into. So that was my my speech. I finished 1 minute early, and I think that was yeah, that's it.
David. I do like to urge everyone actually on that last note to have a look at 7.8, which we released last week, at the end of last week. Particularly our developments around the beats, coming up with a single beat strategy, as well as a new attention for ingest management, how we want to address that going forward. So I really like to urge everyone to take a look at 7.8. I think there's some phenomenal new things in there, and also 7 and 9 and 7.10, of course, that will be coming in the next couple of weeks. I do like to thank everyone, Marius and David. If you have any further questions, let us know. We can redirect them to David, or you can address this directly with Jay and Data. We will follow up with a quick email with the links and an email address of David and Marius if you have any specific questions. And so, yeah, I'd like to thank again everyone for their time. It was very useful. Stay tuned. We're back in August with a follow-up and 2 new topics and 2 new use cases where our customers and partners are using Elastic to solve certain use cases. So thanks for your time and attention, and yeah, have a nice day. Thanks a lot.
Thank you, everyone. Bye.